All right, so we're going to talk about histograms today, and you guys are pretty familiar with histograms. So the definition, a histogram is a graph consisting of bars of equal width drawn adjacent to each other unless there are gaps in the data. The horizontal scale represents classes of quantitative data values, and the vertical scale represents frequencies. The heights of the bars correspond to frequency values. So notice here we have tree heights. So height in centimeters, number of trees. So between 100 and 150, we have this many. From 150 to 200, we have roughly 30, and so on and so forth. Okay. So normal distribution, we talked briefly about the normal distribution. It has this bell shape, similar to the image below. So this is kind of a normal distribution. Later on, we'll talk a lot about utilizing a normal distribution or a population that has a normal distribution. Uniform distribution. So the different possible values occur with approximately the same frequency. So the heights of the bars in the histogram are approximately uniform. Okay, so notice here, there's not a lot of variation in our graph here. So this is fairly uniform. We might have one or two or one. It's pretty close to that. Skewness. So this is talking about, like, a lot of times we'll talk kind of skewed to the right and skewed to the left. So skewedness is the distribution of data is skewed if it is not symmetric and extends more to one side or the other. So data skewed to the right, or positively skewed, have a longer right tail. So this is a positive one here, so the tail is going out to the right. So more of our data is in the left part of the graph. Data skewed to the left, or negatively skewed, have a longer left tail. Okay? So we're going to have a longer left tail, more data to the right side of it. So that's kind of talking about that right and left skewed. All right? So that's really quick about histograms. Most of you guys are really familiar with histograms. You've created histograms in the past.